Hi, my name is Ben Owens. In this video, we're going to look at a mixture problem from a college algebra class. The problem is stated like this. How many gallons of 50% antifreeze solution should be mixed with 70 gallons of 20% antifreeze to get a 40% solution? So before we get into how to work this problem, let's think about what this problem is actually saying. Basically, we have 70 gallons of 20% antifreeze solution. What that means is imagine that we have this bucket or a drum and it's filled up to a certain amount. And this amount is 70 gallons. To say that this is a 20% antifreeze solution means that if we were to somehow separate the antifreeze from the water or the dilute that's in the solution, 20% would be pure antifreeze and the rest would be just water. And so what we're going to do is we're going to add some 50% antifreeze into this in hopes of getting a 40% solution. Basically, if you think the amount that we're adding into it, since it's a 50% solution, means that as we add it, we're adding 50% water and 50% pure antifreeze. That's basically what's going on here. Now, the method that we use in order to solve a problem like this is we make a table. In this table, we're going to have three columns. The first column is going to be the strength of the solution. The second column is going to be the amount of solution. And in the third column, we're going to have the product of the first two columns. So let's see what we have in the problem. Let's start out with the original solution. So it told us that we have 20%, or 70 gallons of 20% antifreeze. So that means that the strength here on this first solution is 20%, and there was 70 gallons of that. So therefore, the product of these two would be 20% of 70. Now, remember when you're dealing with percentages, it's easier to use decimals, and so we're going to write this as 0.2 times 70. Okay? Well, how much mixture, or how much antifreeze are we going to add to that? Well, the next mixture, what we're going to add is a 50% solution. Now the question is, how much of this are we going to add? Well, it doesn't tell us in the problem, and in fact, this is exactly what we're asking about. This is the quantity that we need. Therefore, it is the unknown quantity, and so we use a variable to represent that. So, if we were to multiply this percentage times this number, but it's actually a variable, we're going to have that be 0.5 times x. Now, the last row that we have here is the resulting solution that we want. So it tells us that in the end, we want to get a 40% solution. Now, how much of that solution are we going to have? Well, if we started out with 70 gallons, and we add x gallons to that, then that means that the resulting amount is going to be 70 plus x. And so here in this last column, we're simply going to multiply these. So it's going to be 0.4 times 70 plus x. Now that we have all the information organized in a table, we can use this to solve the problem. How we do that is this. We add these first two amounts, and we set that equal to this last amount. So we're going to write an equation that looks like this. 0.2 times 70 plus 0.5 times x is equal to 0.4 times 70 plus x. Solving this equation will give us the solution to the problem. Now, to make this a little bit easier, we can use a little trick. Since we're dealing with decimals, in order to get rid of those decimals, we could multiply every term by 10. In doing so, this equation will become 2 times 70 plus 5 times x is equal to 4 times 70 plus x. This is a nice trick because now we no longer have to worry about any decimals. Now we can just use whole numbers, which is great. So let's go ahead and work this out. 2 times 70 is 140 plus 5x. And if we distribute the 4 across here, we get 4 times 70 is 280 plus 4x. Now we just have a linear equation, so we need to isolate the variable. So if we subtract 4x from both sides, and we subtract 140 from both sides, this will give us 5 minus 4x is x, is equal to 280 minus 140, which is 140. And this is the solution. This x, since it's here, that is the amount of 50% solution that we wanted, is the solution to the problem. This is how you work a mixture problem. Thanks for watching.